All right, guys, we're going to go over the review for test number 8, which is mostly probability. There is a little bit of counting problems in here, but I think 12 or 13 of the problems revolve around probability, at least somewhere near there. So number 1 on the review, try these on your own first. If you can't figure out how to do it, I don't mind you skipping through the video, finding the ones you don't know how to do. Take some notes. Remember, you only get a 3x5 card for the test. And I don't mind you using this to help you out, but it would be a good idea to try it on your own first. Make sure you know how to do as many as you can before you come to help. So this one says that the spinner at the right is divided into 8 parts. Find the theoretical probability of landing on the given section of the spinner. So my problem wants the probability that I'm going to land on white. So if I look at my spinner, I have 3 white sections out of a total of 1, 2, 3, 4, 5, 6, 7, 8 sections. So my answer is going to be 3 over 8. Now you want to be careful when you're putting in your answers. Some of them want a decimal. I think there's 1 or 2 that want a percent, and others want it as a fraction. You can tell it wants it as a fraction if it just says to simplify. So it wants your fraction in simplest form, and 3 over 8 happens to be simplest form. So number 2. A music collection includes 18 rock CDs, 13 country CDs, 6 classical, and 5 hip-hop CDs. I don't even know if you people know what CDs are. Music discs, right? So part A says, what's the probability that a CD randomly selected from the collection is a classical CD? So I'm looking at the chances of picking a classical, and I know that there's 6 of them. So that's going to go on top. And on bottom, I'm choosing out of all of the CDs. So I need to add them all together. 18 plus 13 is 31, plus 6 more is 37, plus 5, that becomes 42. And 6 over 42 is not simplified. That'll simplify to 1/7. Okay, part B wants the probability that you choose a random CD that is not classical. Be careful of that word not. It's going to show up a couple of times on the test or on the review. So what are the chances that it's not classical? Well, I could count everything that's not classical, or if 1 out of 7 are classical, that means 6 out of 7 are not classical, because only 1 of them is. 6 out of 7 are not classical. All right, number 3. According to a weather report, there is a 38% chance it will rain tomorrow. What is the probability that it will not rain tomorrow? A little embarrassed that you're watching the review for this question, but if there's a 38% chance it's going to rain, the rest is the chance that it's not going to rain. So all I do is take 100% minus 38%, and I get 62%. But it wants me to type my answer as a decimal. So instead of a percent, I'm going to put in 0.62. That would be my final answer. So just remember, the chances of something not happening and the chance of it happening add up to 100%, because those are the only 2 options. Either it happens or it doesn't happen. There's no such thing as it kind of happens. It either rains or it doesn't. All right, number 4. The results of a survey of 100 randomly selected students at a 2,000 student high school are shown at the right. Find the relative frequency of students planning to go to trade school. Remember, relative frequency is just another fancy word for probability, except for this time it's based on actual data. So this is more kind of like experimental probability. The same, we set it up the same way, it looks the same. And it wants what's the relative frequency, or what's the probability that you pick a student planning to go to trade school. So we just look at how many students are planning to go to trade school. These are my community college students, 4-year college, year off, go to trade school. So I have 14 students wanting to go to trade school. Out of, I can either add all these together, or if you remember in the problem, it tells you that is out of 100 students. So 14 over 100, it wants it as an integer, which had better not happen. It bothers me a little bit that that's even an option, because you're not going to get, the only whole number possible would be either 0 or 1, and that's either everybody or nobody. So it just wants it as a simplified fraction, and 14 over 100 simplifies to 7 over 50. So that would be my final answer. All right, number 5. Baby Hugo wants to arrange 4 blocks in a row. How many different arrangements can the baby make? So nowhere in here does it say the word probability. So this is going to be one of our counting problems that we're going to do. Again, there's not a lot of them, but there are a few. And in this case, it wants to know how many different ways Hugo can arrange 4 blocks. So I have block A, block B, block C, and block D. Well, that's one order. Or I could do C, D, C, B, A. There's a different order. Or I could just switch these two and do C, D, B, A. That's the same blocks in a different order. This might start to take a while. So instead, we have a shortcut. We can either use one of our 2 counting rules, either NPR if it's a permutation, or NCR if it's a combination. And remember, combinations, we use NCR when order does not matter, and NPR we use when order does matter. Or in other words, DCBA is different than CDBA. So you're going to use NPR is one way to do it. So in your calculator, you can you're choosing out of 4 blocks, you're putting them in a different order, and you're choosing 4 blocks. That's one way to do it on your calculator. The other way to do it is just the fundamental counting principle, which I've got 4 blocks to place. In this spot, I can choose out of 4 blocks, but I've already picked one. So in the second slot, I only have 3 blocks left to choose from. In the third, I only have 2 left. And in the fourth, I only have 1. So I can just multiply these numbers together. Either way, you're going to get the same answer. 4 times 3 is 12. Times 2 is 24. So there's 24 different arrangements, or you could just write them all out and count them. Lots of different ways to do this one. I like the fundamental counting principle just because it's fast. It's just 4 factorial. But this one give you the same thing. Okay, number 6. Oh, look, I solved it there. For a segment of a radio show, a disc jockey can play 7 records. If there are 12 records to select from, how many ways can the program for the segment be arranged? So out of 12 records total, that's my total records, I'm going to choose 7 of them to play. And here's where we need to decide. Does it matter if I play record 1, 2, 3, 4, 5, 6, 7? Is that different than arranging a radio segment going 7, 6, 5, 4, 3, 2, 1? And I would say yes, order does matter. And in that case, we're going to use NPR. This is a permutation. And the way to do that, remember on your calculator, you put the number you're choosing from first. Out of 12, I'm going to find the permutation of 7 of my 12 records. So it's going to be 12 NPR 7. Now you can do that by hand. There's a formula for that you're welcome to put on your notes the long way, or we can just put it in the calculator. Remember, you put the big number first, the total, and then you're going to hit math, and you're going to go over to probability, and we're choosing NPR because order does matter. And then I put this number, the number I'm choosing second. So out of 12, I'm choosing or doing a permutation of 7 of those 12. Which gives me a really big number. What, 3,991,680? So 3,991,680. Be careful, depending on the number of records it chooses, your calculator might give you an answer something like 2.476895 times e to the 8th power. Remember that e to the 8th means you take this decimal and move it 8 places. So that would be 2, and then that's 1 place, 2, 3, 4, 5, 6, and then I would have to move it 7, 8 places. So your answer, depending on how big these numbers are, your answer might come out in scientific notation, basically. So be careful of that one. Number 7, consider a collection of envelopes consisting of 3 red envelopes, 1 blue, 2 green, and 2 yellow. If one of the envelopes is selected at random, what's the probability that a green or a yellow envelope is selected? So I have 3 reds, I have 1 blue, I have 2 greens, and 2 yellows. And I want the probability of getting a green or a yellow. Well, I have 2 greens and I have 2 yellows. So out of all of them, 4 of them are green or yellow. And there's a total of 3, 4, 5, 6, 8, which simplifies to a half. It wants me to type as an integer, again, no, or a simplified fraction, 1/2. I guess it probably puts that there because there's a chance you could get 1 or 0 as a probability. It's not likely, but it's possible. So I guess it makes sense it's there. Number 8, a set of cards contains 4 suits. 2 are red, 2 are black. It surprises me how many of you don't know cards very well. We might just have to play some card games at the end of the year here to help you get to know what's in a deck of cards. But in each suit, there are cards numbered from 2 to 10. There's also a jack, a queen, a king, and an ace. So it tells you that there's 2 reds of all of these cards and 2 blacks of all of these cards. Consider the following probability for one card selected at random. What's the probability that you select a card that is an ace or a black card? Well, there's 2 suits that are red, 2 suits that are black. Each of those has an ace. That means there are 4 aces. And then all of the black cards together, there's 2 suits that are black and there's 13 in each. So that means half the cards, which is 26, cards are black. Here's where you need to be careful. Normally, you would just take the aces and the blacks and add them together, and that would be your number on top. What we need to be careful of is 2 of those aces are also black, which means I counted them twice. So I've got to subtract the 2 that I counted twice. So there's actually only 28 black or ace cards because 2 of the black cards are aces. And that's out of a total of 52 cards. And it wants me to write it as a fraction. So 28 over 52, that simplifies to 14 over 26, which goes down to 7 out of 13 cards. So my probability is 7 over 13 of picking a black card or picking an ace. Okay, moving on. Number 9. If A and B are mutually exclusive, and if PA equals 0.5 and PB equals 0.4, what is PA or B? Well, remember, PA or B is equal to PA plus PB. That's what we just did in the last problem. We just had to subtract some that got counted twice. But since these are mutually exclusive, none of them are counted twice. So we just need to plug in these 2 numbers. We're looking for PA or B. So P of A is 0.5. P of B is 0.4. So when I add those together, I get 0.9. This one, I think it just wants it as a decimal. I didn't copy that part of the question, so be careful that you put it it'll either be as 0.9 or 9/10 or 90%. I'm guessing it's this one. Okay. All right, number 10. The mathematics department of a college has 9 male professors, 10 female. So I'm going to start writing this down here because it confuses me when it's all mixed in. So there's 9 male professors. There are 10 female professors. There are 11 male assistants. So there's 11 male assistants. I won't abbreviate assistants because some of you get mad when I do that. 8 female teaching assistants. So 8 female teaching assistants. So it wants to know, if a person is selected randomly from the group, what's the probability that the person is a professor or a male? Well, there's a couple of ways to do this. I can take all of the professors. So I've got 9 male and 19 females. So there's 19 professors. And I can take all the males, 9 right here and 11 more, so there's 20 males. And it's an OR problem, so I would add those together. 19 plus 20 is 39. But what I need to be careful of is I counted this group as professors and this group as professors. Then I counted this group as male and this group as male, which means these 9 I counted twice. So I actually need to subtract 9, and that gives me 30 total out of, well, we need to add these together. So 9 and 11 is 20, 30 out of 38, and it wants an integer or a fraction. So that becomes 15 out of 19 would be my probability. The other way is just to count it as professors or males. So I'm going to do this one in, where's my icon? There we go, in red. 9 male professors. Is that group male or professor? Yes, it is. 10 female professors. Is that group professors or males? It's not males, but it is professors, so I include that group. Male assistants. Are they professors or males? They're not professors, but they are males. And female assistants are not male or professors, so I'm not going to include those 8. So it means I'm just going to include the rest of them, which are 30 out of 38, which again simplifies to 15 over 19. So that would be your final answer. Either way works. Just be careful of counting things twice. The table shows differences in political ideology in political science word by education for a random sample of voters. Use the data to solve the problem. So we've got high school people who went to high school only. 16 of those are liberal, 27 are moderate, 12 are conservative. Students that went to college, 11 are liberal, 15 are moderate, 19 are conservative. So it says, what's the probability that a selected person is liberal given that they only have a high school education? So I'm looking for the chance of picking someone who is liberal, but I'm only choosing out of people who went to high school, which means all these people went to college don't matter. I'm only choosing out of high school people. So 16 plus 27, that's 33, 43, 53, 55. So out of the 55 people who went to high school, how many were liberal? 16. That's going to go on top. So my answer is going to be 16 out of 55. That's the chances of picking someone liberal given that they only have a high school education. Okay? So be careful of those given ones. Remember, you're not using everybody. You're just using the group that comes after that little line. That line right there that means given tells you which group you're using. I think we'll have a couple more of those. Yeah, like this one. The table shows the relative frequency of treatments that a veterinarian, wow, words are great. A veterinarian gave dogs and cats during 1 week. Based on the information, what's the chance of randomly picking a dog given that the treatment was shots only? So if I look at my data, 45% of the dogs, 45% of the animals were dogs that got shots only. These are dogs that got shots and a checkup, and that was half of the animals. 25% of the animals were cats that got shots, and another 25 were cats that got shots and a checkup. Well, I'm only interested in given that the treatment was shots only. So this is the group I'm interested in, and total, that group is 0.70. So that goes on the bottom. And I'm looking for dogs in that group. So there's my top number, 0.45. So 0.45 out of 0.7, and it wants a decimal rounded to 2 places. So let's do 0.45 divided by 0.7. And that's going to give me a decimal, 0.642. I'm rounding to the 4, and 2 makes me round down. So my answer would be 0.64. Be careful that you read how to put in your answer. Some of you are going to miss these, even if you do it right, just because you put the answer in the wrong form. 13, 20% of the books in the library are in the fiction section, or excuse me, 20% of the library books in the fiction section are worn and need replacement. So 20% of the fiction books are worn. 10% of the nonfiction books are worn. So 10% of nonfiction. And then it says the library's holdings are 60% fiction. So out of all the books in the library, there's 60% that are fiction. And there are 40% that are nonfiction. Now, for my students, this is extra credit. And if you can find a way to solve it, great. That's up to you. So I'm not going to walk you through the solution. Those of you that are watching from Goodrich or Butterfield's classes, I don't know if this is going to be extra credit on your test or not, but I'll give you a hint. We have a formula, and it's not going to solve the problem for you, but it might get you on the right track. We have a formula that says the probability of being worn, given that I picked a fictional book, is equal to the probability that a book is worn and fiction divided by the probability that the book is fiction. Now, that's nowhere near the entire problem. In fact, you have to make some alterations to the equation, and that'll get you a third of the way to the solution. So, but that's your key, that's your hint. Use that information, see if you can figure out how to solve this one. If you are in Goodrich or Butterfield, you can't figure it out, you're welcome to come see me. I'll help you through that one. Okay, 14. As a financial planner, you're asked to select one stock from each group. So there are 9 local stocks, there are 7 national stocks, and there are 6 global stocks. How many different portfolios are possible? Portfolios is basically a group of stocks, and it wants to know if you pick one from each of these groups, how many different combinations, how many different portfolios could you make? So this one's a counting one, but it's a simple fundamental counting principle question. Because I'm picking 3 stocks. One of them has to be local. I've got 9 to pick out of. The second one, so these are local. The second group has to be a national stock, and I'm picking 7 of those. And the third is global stock, and I'm picking 6. So I have 9 to choose from, then 7, then 6. So all I have to do is multiply 9 times 7 times 6. So 9 times 7 times 6, which means there are 378 different ways that you could build a portfolio of these stocks. Okay, there's 378 different ways you could choose one from each of these groups. All right, 15. In how many ways, if you haven't noticed already, counting problem, that's your key word. In how many ways can a committee of 2 students be formed from a pool of 4 students? So I'm choosing 2 students out of 4, and I'm choosing a committee. And that word implies that the 2 students they're on the committee. One of them isn't any different than the other. The only thing is that they're on a committee together. Or in other words, it doesn't matter if I'm the first student or the second student. Either way, I'm on the committee. So if I have Tanner and Josh on a committee, that's the same as having Josh and Tanner on a committee. Those are the same committees, no matter what order they're in. Or in other words, order does not matter here. So I'm going to use my combination formula, and you're welcome to do it by using arithmetic and factorials, or we can put it in our calculator. We're choosing 4 people, out of 4 people, out of 4 people, we're choosing 2 of them, and the order doesn't matter. So in my calculator, out of 4 people, I'm going to choose, went too far. I'm going to choose 2 of them, and I'm using NCR because order doesn't matter. So there's only 6 different ways to form this committee. So my answer would be 6. All right, last problem, 16. I like this one a lot. Determine the probability of having 5 boys in a 5-child family. Assume equally likely outcomes. That means it's as likely to get a boy the first child as it is the second and the third. Really, let's look at this as you are having 5 children. So this is the first, the one that you really like. This is the second. Then you have the third. I don't know if anyone likes the third child. And then you have the fourth and the 5th child that no one raises because you're sick of kids. So you're having 5 children. What are your chances that the first child is a boy? You have 1 out of 2 chances. I was laughing at a student today a little bit because they were struggling to figure out what's the chance of having a boy. Well, a little education here for you people. When you have a child someday, it will either be a boy or a girl. You are probably not going to have a mongoose. Not going to happen. So you're either going to have a boy or a girl. So that means you have 1 out of 2 chances of having a boy. The second child also has 1 out of 2 chances of being a boy. The third child also has 1 out of 2 chances of boy. So does the fourth. So does the 5th. So what are the chances that all 5 of them end up being boys? You multiply all of those together. 1/2 times a half times a half times a half times a half. Or in other words, you're taking 1/2 to the 5th power, which is 1 over 2 to the 5th power, or just put it in your calculator, which is going to be 1 over 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So as a simplified fraction, you have 1 out of 32 chances that all 5 of them are going to be boys. And that's the test. Remember, you get 1 3x5 card on the test. I don't care what's on it. I don't think Butterfield or Goodrich cares what's on it. You just get 1 card. So put what you need to there. It would be a good idea if you watched this video for all of the questions, please, before you take the test, or even if you watched it for half of them, before you take the test, take your 3x5 card, go back to the review, and choose a similar problem for each of these 16 questions and try to do it on your own. Make sure you can figure that out without my video walking through it. Make sure that you've learned how to do that on your own. And good luck to all y'all.